Hi, my name is André Schreiner and I would like to welcome you to this demo session on the ThinEdge.io open source project. Together with my colleague Sebastian Büttner, who is part of the Edge engineering team, in the next couple of minutes we will give you a short intro into ThinEdge.io and demonstrate how you can use the current preview version to connect your device to Cumulocity IoT, Azure IoT Hub, and afterwards we will also cover some frequently asked questions that we got from users and the community. So, before we start with the demo, let's have a brief look on what the ThinEdge.io open source project is about. So the main objective of ThinEdge.io is to make devices cloud ready without any ecosystem or platform lock-in. So what do we mean by that? So usually many IoT projects, especially in the industrial area, require existing devices such as PLC gateways, protocol gateways, or other types of devices to be connected to an IoT or cloud platform. This usually requires developers to overcome typical challenges such as making sure that connectivity is reliable, secure, but also developers need to enable software and firmware management capabilities so the devices can be kept up to date, for example. And this is exactly where ThinEdge.io can help. It can be deployed on resource-constrained devices such as PLC gateways, protocol gateways. It's super lightweight and only requires a minimum amount of CPU and RAM. And it gives users out-of-the-box connectivity and device management capabilities that they usually would need to build specific to the platform or the device that they use. So let's quickly check how it looks like. So end of March this year, we released the first preview of ThinEdge.io, which includes a set of lightweight modular components which offer the following functionalities. So first of all, I mentioned we have out-of-the-box connectivity to IoT platforms such as Cumulocity IoT and Azure IoT. Initially, we are also working on other support for other cloud platforms, which is coming soon. We support device authentication via X509 device certificates and an easy CLI-based mechanism to generate certificates even for testing purposes or using other types of certificate management platforms. We're using a MQTT messaging bus for the inter-process communication, and we also utilize different mapping mechanisms, so-called data mappers, to map the different MQTT payloads to various cloud platforms or various services that are running on ThinEdge. And this gives users and developers also the ability to create and integrate own components written in any programming language and to be deployed on ThinEdge. So as a next step, and this is what you see in the middle part of the diagram, we are working on open and cloud agnostic device management capabilities such as software management and firmware management with a plugin mechanism that will support different types of software artifacts. Let's take a quick look on the technology stack. So most of the key components that are developed are written in Rust, including the CLI, for example, and the daemon processes, but we also want to emphasize that anyone can contribute components in any programming language by using our plugin mechanisms and the MQTT interface. So regarding the MQTT payload itself, we created a simplified payload format which comes along with various payload mappers for the different cloud platforms and services. But as an alternative, you can also use your own payload standards in combination with corresponding mappers. Now, why should you use and contribute to ThinEdge.io? So first of all, we're a framework. We have created a framework that offers complete freedom. Freedom in terms of which cloud platform do you want to connect your device to, which programming language do you want to use to build ThinEdge components. And the message payload, here we are also completely agnostic. And of course, as long as you're using any type of Linux-based operating system, we can also deploy ThinEdge.io components onto that. The second argument is we are bringing cloud-agnostic device management capabilities. Things like software management, supporting different types of software artifacts like Debian, Docker, or Snaps, firmware management, but also things like configuration management or the resource monitoring of the device itself will be out-of-the-box capabilities that you can again use with any cloud platform. And the third, and one of the most important arguments, ThinEdge is thin, right? So we can run with a minimum CPU and memory footprint. You can see here the system itself occupies less than 16 MB of memory, and it can run therefore on constrained devices where maybe running containers and so on is not even an option. So I invite you to get involved, find out more on ThinEdge.io, the website, check out our GitHub project or follow us on Twitter. And now I hand over to Sebastian to show us a technical demo.
Thank you, Andre, for this nice introduction. My name is Sebastian, and I will now take over for a little introduction, a demo, and show you how you can install ThinEdge.io on your device and get started. To get started, the best idea is to start with the web page. Here you can find some more information. You can find the architecture that was just shown, and you also find a link to the GitHub. That's where we will start now. Here's some information, the links to the documentation, the link to how to install and so on. There's also information how you can contribute and what our reference systems are. You will also find the releases here. So currently that's only 0.1.0, but of course this will change soon. And we will use the how to install now. Can go to the general overview. Here's some more information, a reference guide, something about the architecture in general, and some of the details of the architecture, how it's done. But we will start with the how to installation. For this demo installation, I will use an industrialized gateway. That's the Revolution Pi from Kunbus. That's a gateway with 2 Ethernet interfaces and a little bit more connection options. It's basically a Raspberry Pi 3B bundled into this gateway, so we will use that for the installation now. To install ThinEdge.io, you have 2 options that you see here in the documentation. You can use the installation script, that's the easiest option, or you can install manually, and the steps are also described here. The manual installation is good if you want to keep a little bit more of control to yourself and see what is happening really. I will use the script now for this installation and copy that here. On the right hand side here, I'm already in my terminal and already logged into the device via SSH, and now issue that command. So what is this command doing? It's installing the requirements for ThinEdge.io, which is basically at the moment Mosquito. So this is done in the first place here. It's also downloading the packages then afterwards. And it's downloading the right fitting ones for your device. So it can support ARM and x86. And it's also installing these packages directly. So the installation to run well here and can directly go on. It's also telling me that I can add my user to the attached users group to administrate also the system-wide configuration. In general, I have to do that. On Raspberry Pi, that's a little bit specific because the user Pi has already sudo rights and I don't need that. For normal users that don't have sudo rights, I have to add my user to this group so that he can use the attach command, the CLI tool, as sudo, but only this command and not giving him general sudo access. So after this installation, we can start with the first point of the connection. And this first point is always creating a certificate. So FinEdge is always authenticated via a device certificate. That's true for Cumulocity and for Azure. That's why we start off with that. So we will use the TH command line tool for that. So that's the central tool of FinEdge IO for the configuration and so on. So that's what you will use mainly to configure your FinEdge IO device. And for that, we can always look up in the help what commands we have here. Here we also have the cert command that we will use now. So sudo attach cert. I look here again what it is that I need. Create. So to create a self-signed device certificate. That's very good for demo purposes, POCs, trying around and so on. For that, a self-signed certificate is enough. And I will create that certificate with cert create. And as stated here in the documentation, give also my device ID. So the device ID is usually something like a serial number of the device or something like. So it's a unique identifier for the hardware, the device itself. For this demo purpose here, I will just use probably something like that and hit enter. And now it created a certificate. If I want to see where it's residing, I can use attach config list. And here I see, oh, that's my device ID. And I can also see the key path for the certificate and the certificate path itself. The next step is to connect to a platform already. I will use for this demo Cumulocity, but it can be done in the very same manner with Azure. And yeah, to get started with that, I will access my Cumulocity tenant. And just to show you, we go to the device management. And we don't have any devices here now. What I need to do now is to tell FinEdge IO the tenant that I want to connect to. So I copy that from here, go to my device, and now I can configure this also with config. If I don't know what key I want to configure, I can go to list and doc. And here I have all the possibilities what I can configure. So here we have the Cumulocity URL that I want to configure now. We also have an example given here what format we need to use. So if you are not sure to add HTTP or HTTPS, you can always look up here. And I will do that now. Config set y.url. Okay, and I can look into the configuration again and now have that URL here. One step that is now needed to tell the tenant that this certificate, that root certificate usually, is allowed to access this tenant. So I will upload that certificate, device certificate that I just created to the Cumulocity tenant and do that with attach cert upload. Okay, it's telling me that I have to say where do I want to upload it, and I want it uploaded to Cumulocity, of course, and I need to add my user. So this is just my normal Cumulocity user that I also use to log into my tenant normally. I type in my password, and now the certificate is uploaded. If we go back to the tenant again, on the device management, go to management and trusted certificates. You can now see that here is the certificate that was created just some minutes ago. That's the recent time here that we have listed here. So this certificate is already enabled by default when uploaded by FinEdge.io, and we can also check here the certificate itself if we want to. Yeah, it's a ECDSA certificate, elliptic curve, so it's also safe for the future. The standard validity time of self-signed certificates for FinEdge is 1 year. If you need a longer validity time of the certificate, you can use an option for that while creating it. So in the next step, we can already connect our device now to Cumulocity. And we go to the help again to look up what the command for that is. So we have connect here. And look into that. So we can could connect to Azure now, or we are connecting to Cumulocity. I want to connect to Cumulocity now. So I call sudo attach connect Cumulocity. So what it is doing in the background? So it's now configuring the Mosquito. It's setting up a bridge connection to Cumulocity. It's starting Mosquito, and it's also starting the mapper. So what is the mapper? The mapper is basically translating data from the FinEdge data model that you can also find in the documentation to the Cumulocity or the cloud data model. So of course the different cloud providers have different data models, but with FinEdge.io you don't have to care about the specific cloud provider format. You can just use FinEdge.io data format, and the mappers care about the translation to the clouds. So if you're sending measurements to FinEdge.io, and you can enable Cumulocity or you can enable Azure, it's just configuration, and you don't have to care about the cloud-specific data format. It's also checking the connection. In the first place, in the first try, it didn't work because this call that we are doing to check the connection is a device creation. And of course, the device wasn't there in the first place. But in the second one, it was successful. So we are now connected to Cumulocity. You can also look into Cumulocity again under all devices, and now have our FinEdge device here. So the demo Cebu FinEdge was the ID that I put in the beginning with the configuration. So if I want to send measurements now, I can use our command line tool 2 for that. So we have some publishing and subscribing built in there to make the development easy and to have something for you to test. So as a first example, I will just use that here and copy that again as before. So now I already sent one measurement. I can of course change this to, let's say, the temperature raised to 25 degrees, and then look into Cumulocity again. I'm already in my device and can see this measurement here now. So for the purpose of this demo, I also prepared something else. It's a Node-RED flow. So of course, this cannot only be sent via this command line tool. You can access this directly and easily with any MQTT client you have. That can be Node-RED, that can be from command line. This can be your own program, of course, or it can also be some other software that you are writing. And with this flow, I want to show how easy that can be done. So actually, this timestamp is just triggering this flow, that it's executed every 1 second. Here I get via command line the temperature of the Raspberry Pi and put that value into this format here. So this format is actually the same one that we just used here on our command line call. And we are putting the payload in here. And this flow connects easily to the local Mosquito. So it's just localhost, the normal MQTT port, and it needs no authentication. So with this no authentication and just local communication, it's much easier now to send measurements to the cloud. And your component, or Node-RED in this example, doesn't have to care about the security of the connection, the device authentication, the registration process itself. So that's all on FinEdge.io now, and you don't have to care about it. So we can also go to our device in Cumulocity, refresh one time, and now also see this temperature measurements here in Cumulocity, and that they are coming in every 1 second. To make this complete, I will now also connect to Azure. And I have prepared a little IoT hub for this demo here. So here's my IoT hub, and I can go to IoT devices here. I already have one FinEdge here registered, but I now want to add this new one. So I go to new device, and I have self-signed certificates. So for Azure, the registration itself is a little bit different. So we need a thumbprint here to register. And we can easily get that thumbprint from our command line tool. So for our specific certificate that we created, and we have cert, what's it again? Cert show. And we have the thumbprint here. Copy that thumbprint over. And also put our device ID here. Okay, Azure probably needs some time. Okay, here's our new device. It's not yet connected, so we will do that now. And go to our command line. So first we disconnect from Cumulocity because we don't need that for now. And now directly go to the setting of Azure now. And for that I go to the overview and copy that host name here. And paste that here as Azure URL. That was wrong, so it's directly telling me what are valid keys. So now I have that configured, and I can right away course, I have to spell that right. Right away connect to Azure. It's the same process. It's also building up the bridge for Mosquito and checking the connection, and it was right away successful.
Okay, thanks for the great demo, Sebastian. Now let's come to the Q&A session. We have collected some questions from the users and the community upfront, and we'll cover the most frequently asked. So let's come to the first question. Sebastian, this one is for you. Which devices can run ThinEdge.io?
So of course, we want to support a lot of devices with ThinEdge.io. There are many edge projects in the market that can run larger devices, of course. But we target to support also smaller devices with ThinEdge.io. So we are targeting ThinEdge.io to only need 16 megabyte of memory. We can run on x86 and ARM platforms. And for production usage, there's only one additional requirement that we want to have only Linux systems that have systemd. So to have Watchdog and so on support. This includes also a large area of devices. So this basically can be all Raspberry Pis, all controllers that are based on Raspberry Pis, gateways, industrial gateways, and many sensors directly.
Okay, all right. So let's come to the next one. How are the ThinEdge.io components delivered? I think this one you can take as well.
Yeah, this has also a link to the previous question. So we deliver ThinEdge.io as Debian packages currently. These are directly delivered via our GitHub repo. With our focus on small devices, that was just the first and most common approach for this size of devices. So for more powerful devices, we are open to also support, for example, Docker images or Snap packages in the future, but the Debian packages are the starting point as of now.
Oh, okay, great. So the next one is which cloud platforms are supported? So I can take this one. So of course we built ThinEdge.io in a very open manner. So it's an open source project. So we don't want to dictate anyone what platform you have to use and in your architecture. That means, to start initially in the preview, we are starting off with two cloud platforms. We're supporting Azure IoT Hub and Cumulocity IoT. What you can do with that is you only have to configure these connections with the CLI tool, and you're right away connected with your device to those platforms. If you're missing one of the platforms, whoever wants is welcome to contribute and to add his platform to the list. You can just create some feature ideas in GitHub, and this will be worked on by the community. Okay, so the next one is I want to build my own modules. Which programming languages can be used? Sebastian, do you want to take this one?
Yeah, sure. That's always an important question. So the extensibility of our solution was one of the major points that we had in mind when building our architecture. So we don't want to dictate a language. That doesn't usually work. So we don't want to tell you how you write your extensions. And because of that, we built the architecture so that you can choose. It's built around a central MQTT broker, and the communication between the different components is via MQTT. MQTT libraries are available for nearly every programming language on the market, and therefore extensions to ThinEdge.io could also be written in a large selection of languages. You have to bear in mind, of course, on what size of device you want your component should run. So this is also important for your choice, which programming language you use for your component. ThinEdge.io itself is, for the majority, written in Rust, but that doesn't, of course, mean that you have to use Rust. We just used it because it's small, it's secure, and very good, usable for small devices.
Okay. So, and a very obvious question, how can I contribute to the project?
Yeah, of course. So we are always looking for contributors, and yeah, contributing is not only code contributions. You could also submit PRs to something else, to the documentation or something like that. If you want to fix bugs itself, you can open issues if you want to have a change or describe your motivation for the change. And you could also discuss with us in GitHub discussions, or provide feedback, suggest new features, and so on and so on. I think with this point, we are actually already coming to the next question. So what if I find a problem or missing feature? Who can I talk to? So for that, we also want to use, as we are open source project, we want to raise GitHub issues for that. And I can show you. Okay, so here we are on our GitHub project that you already have seen in the demo. So if you go here to issues, you can see that we already have some issues here. So feature proposals, or if there are any enhancements that can be done, or also bug reports, you can do that here and create the issue, and we will monitor these issues here, and the communication will be here, that later on people that maybe face the same thing can also find it. And it's fully public, so the communication is public to everyone, and yeah.
Okay, great. And there is also a contributing guide for people who would like to know step by step how to contribute. And I think also GitHub discussions is a good forum to exchange ideas and talk about, new features and new functionalities.
Yeah, sure. So there is a contributing guide. There's a couple of steps you have to follow, or we tell you how to do it best if you want to contribute something. And of course, you can also use discussions if you have some questions just and don't want to raise an issue directly.
Okay. All right, we have two more questions. So the first one is, what are the next features on the roadmap? So I'm happy to cover this one. So in our upcoming releases, we will be focusing on the device management functionalities of ThinEdge IO. So we will be providing ready-to-use components, first of all, for the device resource and health monitoring. And we will be also starting with the first components and functionalities in the area of software management. So here we will provide a flexible software plugin framework, which will allow anyone to do additional customizations, and also will help us to support various software artifact types, no matter if you want to manage Debian packages. So this is the first type of software artifact that we will be supporting in the software management. But also down the line, we're planning to support the management of Docker containers or snaps, for example. And yeah, the software plugin framework will also allow anyone to create own plugins, and using also the software language of your choice. Good. So the last question that we have is, can I use ThinEdge IO inside my own commercial product? And the answer is yes. So ThinEdge IO is under the Apache 2.0 license. So you are free to make it part of your own product, deploy it on your own hardware if you want, and run it next to other software components of your device, or deliver it in combination with other software components that you're using. Also, we are planning to have commercial variants of the product, so coming from either Software AG or contributing partners like IFM. And just to give you an example, what will be part of that, of course, it will come with a support package for enterprise customers, and it will also contain new functionalities like streaming analytics, a streaming analytics module, which we are actually working on at the moment, which is an important functionality to do data filtering, pre-aggregation on ThinEdge devices in real time. And for example, this module will be available in combination with the Software AG commercial bundle, and also with the enterprise support package by the end of the year. All right, I think we have answered all the questions that we got so far. Thanks a lot.
feel free to contact us if you have additional questions.
And bye-bye.